So what do we do about solving exponential equations when our bases aren't the same or we don't have a base with an exponent like we see here in these examples? For example, here on example A, we have 6 to the x equals 1,296. I have a base of 6 to the exponent x equals a constant. Well, is it possible to rewrite the constant as a power of 6? Is there a power of 6 that equals 1,296? Something we can do is we can start with what we know. We know 6 squared is 36. If I take 36 times 6, that'll give me 6 cubed. And that equals 216. And if I take 216 times 6, that gives me 6 to the 4th, which is 1,296. So there is a power of 6 that does equal 1,296. So I can rewrite this equation as 6 to the x equals 6 to the 4th. Let's write that so that we can see that this is actually a 4. And now that I have the same base, I can say, okay, in order for these two sides of my equation to have the same value, the exponents must have the same value. Therefore, x must equal 4. So I have 6 to the 4th equals, as we know, 6 to the 4th. But when we look at B, I have two exponential expressions. I have 9 to the power of x, and I have 3 to the power of x plus 2. They're not the same base. But one thing I do know is 9 is the same thing as 3 times 3. And 3 times 3 is the same thing as 3 squared. So I can write 3 squared in place of 9 to the power of x equals 3 to the x plus 2. And then if we remember our properties of exponents, when I have a power to a power, I can multiply my powers, I can multiply my exponents, and I can write this actually as 3 to the power of 2x equals 3 to the x plus 2. Now that I have the same base, and in order for each side to have the same value, my exponents must have the same value, so 2x has to equal x plus 2. Isolate an x, so we subtract x from each side, and we have x equals 2. Now, in order to check this, I would need to check for the values of each of these sides because I don't have like bases. So we can check to see if the values work. Is 9 squared going to equal 3 to the 2 plus 2 power? 9 squared is 81. 3 to the 2 plus 2 power is the same as 3 to the 4th, which is also 81. So x is, in fact, 2. And finally, on C, I do have, again, two exponential expressions, but this is different even from example B because there isn't a power of 4 that will give me 8. 4 squared is 16. So I need to think, is there a number that when it's written to a power will give me 4, and that same number when written to another power will give me 8? I know that 2 squared will give me 4, and if I take 4 times 2, that's 2 cubed, I will have 8. So I can rewrite 4 as 2 squared, still raised to the 2x power, and 8 can be written as 2 cubed, raised to the x minus 2 power. And then just as I did in example B, I have powers raised to a power, so I can multiply my powers. I can multiply my exponents and write my equation as 2 to the power of 4x equals 2 to the power of 3x minus 6. Now I have the same base. I have exponents on those bases, and if the two sides are going to have the same value, the exponents have to have the same value. So I can set them equal to each other. I'm going to subtract 3x from each side, and x equals -6. Now, we can have negative values of exponents, but it's not going to be so easy to check for values if I substitute it into my original problem, because I'm going to end up with very small numbers. I'd probably have to plug it into a calculator. So it would be okay as long as I know that I've done all of my work getting my bases the same, and I've converted them correctly, and I've simplified correctly here. It would be okay to check right here at this step of 2 to the 4x equals 2 to the 3x minus 6. So that's what I'm going to do, is 2 to the 4 times -6 going to equal 2 to the 3 times -6 subtract 6. That's the question I'm asking myself. So 4 times -6 would be 2 to the -24 equals 2 to the 3 times -6 is -18, subtract 6 is also -24. So as long as what I've done prior to this step is correct, I should have done my work correctly, and 2 to the -24 equals 2 to the -24. If you want, you can plug this into a calculator and see if you get the same values as well. And this is the first video on solving exponential equations that have different bases.